안녕하십니까. 저는 2019 이러닝코리아 컨퍼런스 1일차 트랙 D-1번 트랙 좌장을 맡은 한국교육학술정보원의 유재욱 책임연구원입니다. 지금부터 이러닝 컨퍼런스 트랙 D1 학습분석 기술의 글로벌 트렌드를 보다 세션을 진행하겠습니다. 이번 세션은 아마스의 아민 카지 총장님께서 두 개의 주제로 발표를 하실 예정입니다. 첫 번째로 발표할 주제는 견고한 학습 분석 시스템을 위한 IMS 글로벌 표준 활용 사례 소개이고, 두 번째로 발표할 주제는 데이터 수집 분석 플랫폼 구축 사례 및 글로벌 에듀테크 동향 소개입니다. 이번 세션은 두 개의 주제를 연속해서 발표자님께서 발표하는 시간을 갖고요. 발표가 모두 끝나는 두 가지 발표가 모두 끝나는 이후에 20분간 참가자와 질의응답 시간을 가질 예정입니다. 참가자들께서는 프로그램북과 지금 앞에 스크린에 있는 없는데요. 스크린에 있는 QR 코드를 촬영하셔서 모바일 실시간 질의응답 시스템으로 입장을 해주시면 됩니다. 강의를 들으시면서 궁금한 점이 있으시면 이곳에 질문을 올리시거나 질문에 공감을 표시해 주시면 강연 종료 후에 제가 연서분께 직접 질문을 드리도록 하겠습니다. 많은 참여를 부탁드립니다. 먼저 아민 카지님의 발표를 시작하겠는데요. 아민 카지님에 대해서 간단하게 소개를 좀 드리겠습니다. AMS 대표로 지금 계시는데요. 이전에는 지나는 디지털 교육에서 데이터와 분석에 중점을 둔 대학 컨소시엄인 유니진의 창립 최고 경영자로서 활동을 했습니다. 유니진의 솔루션 중에 인게이지 솔루션이 있는데요. 교수진이 온라인 학습 자료를 통해서 학생들과 함께 구성하고 전달하고 상호작용하는 그런 콘텐츠를 데이터를 실시간으로 전달해서 측정하는 사용 패턴을 볼 수 있게 하는 솔루션입니다. 또 이를 통해서 학생들이 어떤 주석을 달았는지 어떤 활동을 하고 있는지를 실시간으로 교사들이 활용할 수 있는 그런 솔루션인데요. 이를 가능하게 하는 것은 지금 발표를 하실 학습 데이터 수집 표준인 IMS 글로벌의 칼리퍼 어널리틱스 표준, 이런 기술들을 사용했기 때문입니다. 아민 카시 대표님의 첫 번째 발표를 통해서 다양한 에듀테크 기술이 교육을 어떻게 변화시킬 수 있을지 인사이트를 발견하시기 바랍니다. 첫 번째 발표 주제는 AI, 머신러닝, 빅데이터가 어떻게 교육을 변화시킬 것인가입니다. 아민 카지,
Thank you very much. Is this on? Sorry. Can you hear me okay? So thank you. My name is Amin Qazi, and I am with a small company called Amass in the US. Previously, I held many different types of roles. Most recently, I was the founding CEO of a consortium called Unizin, and what Unizin was really focused on was the use of data and analytics to improve learning outcomes. So I did that for a number of years, and then I had an opportunity to go work with some other really interesting people. And what I realized was having one job is no fun, so now I have 3 different jobs. I consult with University of California at San Diego on their data architecture. I work with IMS Global as the co-lead of their Caliper Product Steering Committee, and we'll talk a lot more about that in a minute. And then also with a company called Greenlight Credentials, I'm a special advisor. So today, this morning, the first half of this, we're going to talk about IMS Global. We're going to talk about some of their solutions, how they can help build a teaching and learning analytics practice. And then in the second half, I hope you all stick around for that, we're going to talk more about AI in universities and how artificial intelligence and machine learning can be used. So this morning at the keynote, we heard a lot about how artificial intelligence is going to change education and teaching and learning. I think some of that is true, but I think there's a lot of hard work that needs to happen in order to get there. So in the second half, I'm going to talk a little bit about some of that hard work that we've been doing. So how many people, raising your hands, how many people here know what IMS Global is? Okay, very few. Good. So this will be new to most of you. So IMS Global is a worldwide consortium, and what they do is they help establish standards for teaching and learning technologies. A lot of that happens in the analytics space and the interoperability space. So we'll talk a little bit about that. So first I'll talk about open badges and the comprehensive learner record, which is basically the transcript or your educational records. And I'll talk about some of the work that Greenlight Credentials is doing using those standards. I'll talk about Caliper and data and how University of California at San Diego is using those with Open edX. And then I'll talk about some of their emerging standards that IMS Global is coming up with as well. And then I'll go into some examples about how other people are using it. So before we get into all of that, I just want to say that IMS Global has a really great conference called Learning Impact Leadership Institute. They call it LILI for short. It happens next May in Denver, Colorado. It's a small conference. It's probably about the size of this conference, but there are a lot of great conversations, a lot of great information there. So if you are able and you have time, you should really try to go there. And Denver's a great place to hang out as well. Open badges and comprehensive learner record and Greenlight. So part of the problem, especially in the United States, is that there are a lot of colleges and universities that are shutting down. And when those colleges and universities shut down, the students' academic records are lost forever. So in some cases, they can be transferred to other institutions, but in many cases, they're just gone. The other problem is that there's this issue of fraud that happens worldwide. People claim they have academic records they don't have. It's very difficult for us to verify them. If I said I had a PhD from any number of universities, I can say that. I can put it on LinkedIn even, but it's really hard for anybody in this room to verify whether or not that's true. So what we've been trying to do at Greenlight Credentials is how do we have better learner records management to improve learner outcomes, and how do we use IMS Global's digital credentials ecosystem to support that? Sorry. So there's a lot of different pieces that go into this. So it's colleges, it's schools, it's employers, universities as well. And there's three different parts that IMS Global is working in. So the first is around open badges, which many of you have probably heard of. Those are badges that can be awarded for various things. There's a comprehensive learner record. So this is your entire history of your education from when you were a little boy or girl until you enter the workforce. And then there's competencies that are attached to that. So just completing a course is no longer enough. You have to prove that you have certain types of achievements. So some of these principles that they have is we wanted to make sure that the learners had agency, so that just as easily as you can pull up your bank account on your phone, you should be able to pull up your academic records on your phone as well. We wanted to make sure that employers could connect to you based on the skills that you have. So rather than you going out and looking for jobs, the jobs should come looking for you based on what you already know. And we want to make sure that this is lifelong learning. It doesn't end when you finish university. It goes on for the rest of your life. So Open Badges is a digital credential that is issued by many, many different organizations. Anybody can issue an open badge. The person who issues that open badge is the one that's verifying that academic record. And there is, sorry. So there's more than just a record. There's a lot of information inside of that happens as well. So for example, at IBM, IBM has an open badge program. Their employees can go and they can receive badges for things that they've done in the workforce. If they completed a big project at work, they can get a badge for that. If they've completed certain training, they can get a badge for that as well. So this open badge is really what it allows anybody to do, both employers and educators, is it allows them to reward achievements to their students. So when we looked at how do we make sure that the comprehensive, make sure that the lifelong learning is recorded, one of the main things was open badges, and IMS Global's open badge standard helped us with that. The other thing that IMS has done is they have built this thing called a comprehensive learner record. And like I was saying before, it's not just about what courses you may have taken in school. It's also co-curricular learning, which are things that you do while you're in school, if you have a job or you're volunteering your time. If there's competencies that you've gained, if you speak a second or third or fourth language, how do we make sure that we track that as well? At the bottom, you see badges again. That was really important. So some of the use cases for this are on here. I won't go through all of them. But again, the idea is that it's not just your university record that we want to track. We want to make sure that this is a lifelong learning record. And we want evidence of learning as well. So we want to make sure that when someone sends you their academic record, you can see the evidence of all of this learning, and you want it aligned to competencies. So again, IMS Global has this thing called CASE, which is a competency framework, and I'll talk a little bit about that, but not much. But really, that's how all of that works. So in higher education specifically, there's data that comes from the student information system, from the learning management system, from adaptive learning systems that are available, and they all come together into this single academic record store. And so the way the CLR works is it's very, again, I'm not very technical, but I can pretend a little bit. It's really just about how do we store that record in a format that's standard that can be shared around the world very easily. So there's this data architecture that has all of these different types of achievements. There's alignment with different types of things that can happen in there as well. So when we look at the comprehensive learner record and we look at the extended transcript, really what this is again, there's a lot of different parts of data that come together into a single record that need to be issued out. So when you look at what IMS has done around the comprehensive learner record and around open badges, it really helps us do some of those things that we talked about earlier, which is how do we have students own their own educational records? So rather than the institution owning them, how do we own them? How do we make this all digital so there's not paper going around in a lot of different places? How do you make it easy for it to be instantly verified? So one of the other challenges that we had to solve was these different types of achievement data. So if I did a study abroad in France and I took courses there, and then I also took courses in the US, and then my work sent me to her training, all of those live in different places. So what we needed to figure out is how do we have a shared ledger in order to have all of these different records come together? And the answer to this was, like a lot of different places, it was blockchain. So we use blockchain in order to bring together all of these different academic records, badges, university records, workplace learning, into a single place. So it allows us to make sure that everything is secure. It allows us to have a peer-to-peer network, so there's no central organization that's managing the data. The institutions themselves get to share it. Again, there's no owner. And then it's immutable. And what immutable means in this specific case is that it can't be changed. Once an academic record is written to the blockchain, you can't go back and change it. You can update it, you can have a new one which goes above the old one, but you can't change the record on there, which again makes it very secure. So part of this is we wanted to also make it easier for students to go from their high school to university into the workforce. So really we wanted to make sure that we could reduce some of this friction, and we wanted to give students control of their records. And all of this is built on IMS's open badges and comprehensive learner record standards. So anybody can take these records, they can move them into any other system. So what we did at Greenlight is we built this distributed ledger that allows for peer-to-peer connections across multiple institutions and around the world. So again, it's distributed, it's trusted, it's verified, and there's some other features as well. So Greenlight Credentials is a platform which is available right now. It allows students to go and look at their academic records from multiple institutions. It allows high schools and colleges and universities to find students, to give students scholarships, again, rather than the students having to apply to many universities. The universities just come to our platform. They can find the students they want. They can send them invitations. And similarly, employers can do the same thing. So rather than have students go out and apply for a lot of jobs, it was really about how do we use the comprehensive learner record as a searchable document that employers can go and search against. Sorry. So again, these were some of the goals that we had, and for institutions, for colleges and universities, we really want to make it easy for them to receive and issue student credentials. If a student moves between different universities, we wanted to make that really easy for those credits to transfer between the universities. For students and applicants, we wanted to make it really easy for them to control their own academic records. So like I said before, it's like having your bank records on your phone where you can look at your bank records as many times as you want and you don't have to pay. In the United States, sometimes it costs up to $50 to get your transcript sent to somebody, and you don't really get to see it or review it. We eliminate all of that. And then finally, for employers, we want to make sure that this is based on a verified understanding. So solutions like LinkedIn, which are very nice, and I'm on LinkedIn as well, it's hard to verify what people put on there. So we wanted to make sure that was verifiable. So because of IMS Global and their standards, Greenlight Credentials today has 1.7 million academic records stored on the blockchain. And to our understanding, it's the largest verified distributed ledger of academic records in the world. And this is expanding right now. So what this solution really was built on was the IMS standard. And similarly, I'm going to talk about Caliper as well. So Caliper is a IMS Global standard that really focuses on data and data movement. So it's a way to describe what happens in any educational system. So Caliper, again, I'm part of the Caliper product steering committee. I have many criticisms about Caliper, probably more than you, but also I realize that there's some benefits in it as well. So I'm going to talk a little bit about what Caliper does at a very high level. I'm going to talk about how you can use Caliper, and then I'll talk about how UC San Diego has implemented it. So at colleges and universities today, there are many, many distributed applications, which means that there's a lot of distributed data as well. So this data is really intended to support teaching and learning. There's data that comes from systems, it goes into some repository now, and then it goes out to a bunch of analytics and insights. And where Caliper lives is in this little space between the student information system and the data repository. So it's not intended to be a full data warehouse solution, it's not a learning record store, but it's very much about this little piece. And the way Caliper works is it just has a standard vocabulary. It makes it very easy for a system to describe something that happens to another system. And I'm going to talk a lot more about this in detail, but that's really the general idea behind Caliper. And I think once you understand that, Caliper becomes a lot easier to understand. So it's about these. And the way these all come together is inside of what IMS calls a model. So there's a model inside which lives a profile, inside which lives an event, and then inside of that there's a lot of other things. So the way this is represented in a computer is this is simply a JSON file, the JSON structure. There's some required things that you have to have at the top, and then there's a lot of optional things. And that's both the positive and negative about Caliper, is that Caliper is very, very flexible, so you can have as many of these extensions at the bottom as you would like, but that also sometimes makes it more challenging. So again, this is a simple JSON file. This is a real Caliper event that I de-identified. This is basically how Caliper comes out. So the way Caliper looks normally is, again, there's a person, so Amin, he does something, I posted, and then a message. So this is basically what the Caliper event is, and all the JSON around it is is fine, but it's also important to know when this happened. So this is the minimum you need for Caliper is somebody did something to something else, and then at what time did that happen? But as you can imagine, the minimal requirement is never that useful because there's so many other things that happen in a teaching and learning environment. So this is where Caliper really becomes powerful for colleges and universities who are building tools and EdTech providers who are building these tools. It allows them to have a standard vocabulary where they can describe events that happened in their system. So I won't go into this too much right now, but I will later. So currently, Caliper has a lot of different profiles. So they are adding more and more all the time. They're on Caliper 1.1 right now. They're expanding all of these. And just as an example to kind of go in a little bit deeper. So if you look at the media profile, so if you look at video players or audio players that are used in the classroom, these are all the different types of events that Caliper can capture standard. And of course, again, you can have extensions that do a lot more. But you can know immediately when a student turns up the volume on a video, you can be alerted of that immediately. When they pause something, when they start something. All of those real-time events become really powerful, and I'll talk more about how we're using those in the second half of my talk. But Caliper has really extended a lot of that. And the reason why that becomes really important is because it promotes interoperability. If you have 2 or 3 or 4 different systems and they all need to talk to each other, Caliper is a standard format that they can all adhere to. It enables innovation. So on the data stream, so the data is coming out in real time, there are live events that you can use to alert students, to alert faculty, to take other actions. A lot of adaptive learning programs now are built on this aspect of Caliper. And then there's insights as well. So Caliper comes in, it gets stored into your data, into your learning record store, and then you can do a lot of analytics around it. So how did we at UC San Diego get started with Caliper? So I'm going to go through like 5 or 6 steps. It's relatively simple and straightforward, although it gets a lot harder. So IMS Global has issued what their specification is for this. So you should go and read the Caliper specification. It really explains how things work. And then once you understand that, you should figure out an experiment. It's really important to have a real use case that you can build this on. So here again, as an example, you can take your video player, whatever it is, and you can start extracting Caliper data from that. There's reference implementations that are already there. So depending on what language your program was written in, there's a lot of different pre-written code that you can already use to pull data out. Or if you have a lot of time or you're very unique, you can do what Purdue did, and they wrote their own sensor for the iOS platform. And then it's just a matter of implementing the profiles. And I don't mean to make this seem overly simple, but once you understand what Caliper is and you are able to get the data out, it's relatively simple to use the sensor API to start implementing these profiles to get this data out in real time. And again, these are just examples that we've done from OpenEdX. And then you want to send it to an endpoint. So you have this data coming in. You can delete it, obviously, but that doesn't provide a lot of value. So how do you decide where this data is going to be stored? At UC San Diego, we built an architecture where there's tier 1 storage on SAP HANA, which is a very fast database, and then there's slower storage for other types of analytics. And then what we've done is we've taken that data and we've built different types of reports off of it. So there's all sorts of data that's available in these systems, and they make it very easy to build these types of reports from that data without doing a lot of additional work. It's all very, very simple and straightforward, usually. And then there's additional profiles as well. So you can take what you've done today, you can extend it very easily. So one of the examples I'm going to talk about, so those 8 steps, what we did is we took OpenEdX, which is a open source platform that many people use. UC San Diego wanted to use it as well, and they asked me to help them figure out how we get data from OpenEdX into their learning record store. So For those of you who don't know, OpenEdX has a very closed ecosystem. They don't make it easy for data to come out. And a lot of the needs that we had at UC San Diego to get the data weren't met by the current solution. So it didn't have all of the events that we wanted. It didn't do it in a standards-based format. It only did it in the OpenEdX format. It was very, very slow. It just wrote it to a database. You had to go do a lot of querying, and then it wasn't easy to get to that database anyway. So we went through this and we did the analysis. So like I said, you kind of have to figure out what your solution is going to look like. We wanted all of the events, and OpenEdX only had 86 of them that we could map, so we had to do some additional mapping ourselves. It didn't have clear events on some things, like when a student logs in. That's very important to have in real time. So what we did is we took the OpenEdX data and we coupled it with Google Analytics data as well, so we can start tracking some of those types of things. OpenEdX wasn't really written in a standard format, so we had to do some conversion to that. And then it didn't conform to any standard at all, so that was something else. And then finally, it wasn't in real time, so we really wanted this data to happen in real time. So what we built is we built a sensor that looked at OpenEdX log files second by second, so we could pull out data in real time. So a lot of these didn't map clearly. And again, Caliper is great, but in a lot of ways, it slowed us down from doing what we wanted to do. So where we could, we followed the Caliper standard, and where we couldn't, we did our own thing in order to get us to where we wanted. So again, we took the data that was available, we mapped it to our learning record store. We took the JSON that we converted, we built our own JSON converter in OpenEdX, we mapped it to Caliper, and then all of the data that came out, it was really easy for us to map it to everything else that we had. So this is, again, each of these different sections show where the different types of data ended up. So what we learned from this is a lot of data comes out. So at University of Michigan, they are using Caliper, and they're getting about 1.5 million events per day. That's, again, it peaks on Mondays and it goes down as the students are less engaged in the course. But this generates a lot of data very quickly. There's a lot of action that you can take on it. So this OpenEdX solution that we talked about is open source. Anybody who uses OpenEdX can use this and get Caliper data from their system. So this is available. If you have any questions, you can reach out to me. I'm responsible for it, good or bad. It was something that I worked on a lot. So that's just an example of what Caliper can do and how it can really inform a lot of your data and analytics. So the last part I want to talk about is around LTI, which is Learning Tools Interoperability, and then Edu API and LTI Advantage, which are two emerging standards that IMS is working from. So for LTI, the problem that they were trying to solve was there's a lot of different tools, and how do you make it easy to talk to them? And then additionally, what they wanted to have was they wanted to have some way to get real-time data from the LTI integrations as well. So when two systems are talking to each other, how do you get additional data out of it? So again, LTI is a very common, it's a language that they built to have educational systems talk to each other. It works for the most part, but there's three different things that it does. So it connects two different systems. It makes sure that the two systems are conforming to different types of standards, and it allows some light data exchange between the two. So it allows you to securely connect learning platforms and tools. It confirms the tool, the user, and the context. So when you have single sign-on through LTI, it's actually the LTI layer that's doing a lot of that verification between different systems. And then it also allows some of this learning, this data exchange as well between the different areas. So again, LTI, this is what it does. And then what LTI Advantage is really built on, it's built to allow more data to go through. So how do you have names and role provision go between different systems without having to build it into each system? How do you have, so this is that first point about how do you exchange users between different systems? How do you have deep linking? How do you make sure that when somebody clicks on something in one application, that click is transferred to another application smoothly and securely. And then finally, it's really about assignments and grading services. So how do you make sure that all of these are being able to speak to each other? So LTI, one of the things that they spent a lot of time on was making sure that it works with your sign-on system. So it supports a lot of the open standards that are out there for authentication and verification as well. So one of the ways that they're expanding this is something called Lti Insights. And this is currently in early adoption, so I'm working at UC San Diego to help them pilot this as well. But really, this is how do you bring LTI and Caliper together? And this is early. For those of you who come to the November meeting for IMS Global, you'll probably hear a lot more about this because it'll be further along. So the other part of this that that IMS Global is building is this thing called EduAPI. And what EduAPI is, it's a way to have more data around from systems so they can talk to each other. So just like with LTI, it's similar to that, but it's built out to be more open and more powerful than what they had before. So overall, there's a lot of things that IMS Global is working on. And again, I'll say this Learning Impact Leadership Institute, Lili, is a great place to go visit. There's a lot of really smart people there who are working on really cool things. And then also they have these Learning Impact Awards as well. So if you or someone you know is working on something that's really innovative, you should submit your proposal to them. It's a really big honor to be recognized by IMS. So I would say that that's something else that you want to do. So that's the first half of the talk about IMS Global, and I don't know if we have time for questions, but I don't know if we want to save all the questions for the end or how we want to do this. Sorry.
예, 지금은 첫 번째 발표 시간이 끝났고요. 질문을 이따가 한꺼번에 같이 받기로 했었는데 그렇게 하는 게 나을 것 같습니다. 그래서 잠깐 지금이 2시니까요. 네네. 일단 첫 번째 발표가 끝났고 지금 첫 번째에서 굉장히 많은 얘기를 해주셨어요. 그래서 IMS 글로벌에서 하고 있는 여러 가지 표준들에 대해서 거의 뭐 하루 종일 들어야 될 것 같은 그런 주제들인데 지금 굉장히 짧은 시간에 요약해서 말씀을 잘 해주셨고요. 이제 두 번째로는 이런 IMS와 이런 국제 표준들이 어떻게 구축이 되고 있는지 그런 사례들 그런 것들을 발표를 바로 이어서 좀 해주시고요. 왜 끝나는 대로 질문과 응답을 하겠습니다. 그래서 그 아까 말씀드렸던 그 QR 코드로 접속을 하셔서 질의응답을 남겨주시면은 일단 한꺼번에 같이 질의응답을 하는 게 좋을 것 같습니다. Continue your presentation, maybe. Continue.
I thought there was a break. I thought there was a break. Want me to go second half as well or no?
지금 같은 발표를 계속 이어서 하시느라고 한 3분 정도 잠깐 쉬셨다가 하는 게 좋겠다고 말씀하셨어요. 잠깐만 쉬셨다가 하겠습니다.
Hi, again. I apologize for that. I get tired of hearing my own voice, so I thought you might need a break as well. So that was about IMS Global, and now I'm going to talk about some of the stuff that we heard this morning in the keynote. For those of you who heard the keynote, it's really about AI and universities. So we hear a lot of, I'll be honest, I disagree with some of what the keynote speaker said, so there's a lot of hard work that comes with this. I think a lot of what he said was great, and I'm going to talk about, I'm going to talk a little bit lower level than what he was talking about. So you hear a lot of stories about AI is going to change the world and it's going to take people's jobs and all these things that may or may not happen, but I'm going to talk about really what that looks like for us on the ground who are actually working with students and with the data. So we heard a little bit about this morning about how AI is really going to have some economic impacts, and I think a lot of these are right. It's going to be cheaper to do some things. I think there's going to be some portions of our jobs that are going to be replaced by AI. There's going to be different types of business processes because of it. So all of these I believe to be true. What you see in the market is you see a lot of venture capital, a lot of money going into EdTech solutions. So this last year, it was $152 billion US dollars, and that's going to more than double in the next 7 years. So there's a lot of money that's going into this. And the money is going into many different places. So teaching and learning is not really how higher education is going to change immediately. It's going to change in a lot of different areas first. It's going to change in how do you do customer support for students? How do you do assessments? How do you make sure that you have students coming to your university and staying at your university? So a lot of the I think stories that you hear about AI is going to replace all of the teachers and all of the universities. I think that is very, very far from the reality. And in order to explain to you why I think that, I'm gonna go explain how I think about AI and then how it actually is applied or can be applied in our area. So there's different types of AI as well. So everyone says, oh, AI is going to change everything. There's different things to it. So one is around vision intelligence. So how are you able to look at something and allow a computer to make a decision about it? There's voice intelligence, which we all have on our phones, but how do you make those more intelligent? There's algorithm intelligence, which is really about how do you look at processes, how do you make processes more efficient? And then there's inference intelligence, which the last one is really about pattern recognition, and computers are great at that. That's really powerful. I think that's really where AI is going to make a big difference, but I think that's also the hardest place to go first. So if you look at how educators have been thinking about this, and this is from a survey, the highest impact is going to come from the algorithms and the process improvement. A lot of these things around vision and voice in the classroom, they're going to be very, very difficult to achieve. One of the things that was said this morning was around translation services, and I think some of those may be true, but that's a very small part of education and of teaching and learning. So I think that part of it is going to be much harder to achieve. So this is for people who are busy and want to get back to checking their email. This is really what I'm going to talk about today, is that AI is really important. It's going to change how you manage your data, how you interact with people, and it's really critical. And the hard part is it's not actually implementing AI. So I work with a handful of organizations that are trying to bring AI into their university or into their company, and it's never about the technology. It's more about the processes, about the leadership, about the strategy. So that's really what I'm going to talk about. So universities are really complex. I'm specifically going to talk about artificial intelligence in the education space, but I think this is broadly applicable outside of that as well. So universities do a lot of different things. They have HR, they have to pay their employees. They obviously do education. There's a lot of research that happens there. There's logistics. They have to have stores. They have to bring food in. They're basically large restaurants in some cases as well. There's a lot of different things that they need to do, but also they don't think about these things in a very modern way. They don't think about these in a way that companies who are need to make investors happy, for example, or need to raise the next round. They think about these things very differently. And it's a shame because we all know that AI really helps organizations do better. So the use of artificial intelligence in a thoughtful way improves efficiency and improves customer satisfaction. It helps companies do better analysis. And the companies that are growing fastest today are the ones who are already embracing artificial intelligence. So there's some causation / correlation there as well, probably. But really what you see is that the organizations that are thinking more forward about this are moving faster than their counterparts. So the real question today is can we get, as a university, as educators, can we get to the AI promised land? And the answer is yes, we can, and then in some cases, no, we can't. And also, it's not going to happen this year or next year either. So AI is a very big topic. There's a lot of things that we could talk about. I'm not really going to talk a lot about operations. Around talent management, the resourcing to build an AI practice at your organization is a really big deal. So I'm not really going to get into that because it takes a lot of time. And then there's regulations that governments are going to come in on, and then there's ethics as well. The one thing I do want to talk a little bit about is biases. So one of the things that you hear a lot is that AI is biased and it's just going to make the world worse. AI can be biased, but it's not biased because of the algorithms themselves. The algorithms are very, very neutral. Where the biases come in is around the data. So if you bring in data that's faulty, the algorithm's gonna magnify that. The objectives, the designers and the programmers. So we're all human. We all have our own biases that we bring into these as well. So when someone says to you that artificial intelligence is biased and that's the reason we shouldn't use it, you can tell them that I said that's not true. So what is artificial intelligence? What is machine learning? I want to talk about this a little bit just so we're all using the same language. So machine learning is really the ability for a machine to learn without being programmed. So what that means is that a machine can understand something, it can synthesize the data and put out some result. What artificial intelligence is the machine's ability to take action on that information. So that gets a little bit more complicated. And inside machine learning, there's 3 different types of learning. So there's reinforcement learning, which is really on your left side is around, that's the type of learning that happens with self-driving cars, for example. There's supervised learning where you all have this, where it says click on the 3 horses in this picture and you have to click on the horses. They know what they're looking for. And then the last one on the closest to me is predictive learning. So what this is, programmers went in and they said, here's a human body, and they gave it some restrictions around how it could move. Its arms can't move backwards, whatever. And it told the computer, find the most efficient way to jump over these ledges. And the computer found that this was the most efficient way for humans to go and jump across ledges. None of us would do that, but that's how, again, with a set of parameters given to the computer, that's how the computer decides that. So this morning we also heard about IBM Watson. IBM Watson's come a long way since 2016. So in 2016, they partnered with a food magazine called Bon Appetit, and they gave it a couple of 100,000 recipes, and they said, AI, go ahead and make us some new recipes. So this was a cocktail that came up that has beer in it, has veal stock, has wine, has sugar. So like these are things that AI is not really good at, despite what people think. AI doesn't have taste buds. It'll never replace a good chef or a good home cook. So it's fun and it's interesting to allow experiments like this to go on, but it's never actually going to replace what we do. But what has happened since then is that AI has found a very, very narrow area that it can work in. So at Amazon, which everyone knows, its warehouses are all run by AI. So you have these little machines that are running around moving product from one shelf to another shelf. None of that is programmed in. All of that is done through artificial intelligence. For those of you who use AWS for your applications, or you use any website that uses AWS, which is probably half of them now, a lot of that capacity planning happens using artificial intelligence. There's no lead data center engineer deciding when they put more servers in. That's all done via artificial intelligence. And Amazon has a few prototype stores that they call Amazon Go. And the whole concept there is you walk into the store, it's a small 7-Eleven CVS type store, and you can just pick up whatever you want and you walk out and they charge you. They know what products you've taken and they know how to charge it. But they don't do that using RFID tags or anything like that. They use cameras and they watch your body language. They watch how you move and what you pick up and what you put back. And based on that, the AI decides this is an item that Amin has put in his basket or has not put in his basket, or this is something that he's put back, so we're not going to charge him for that. So that's all done via AI as well. So AI has very narrow, I think, applications, but they're also really, really great. And I think that's the other part that people miss when they talk about AI. So there's two different, there's a whole spectrum of different things that can happen around AI. So on one side, it's how do we do what we're doing today, but we do them better, we do them faster, we do them cheaper. That's a really, really simple to understand concept around artificial intelligence. What's really, really challenging is how do you do something radically different? So how do you use cameras to recognize body language so you don't need someone to check you out when you go to the CVS, for example? So this whole spectrum, it really colors a lot of the conversations around AI. And I think when people say AI is going to take over the world, I think they're talking about everything that's happening on the left side, but the changes really are going to come in on the things that happen on the right side. So why isn't excuse me? So why isn't this going to happen? I think there's a big challenge around data, and I'm going to talk about data a lot because they are just really important. It's not the challenge with AI. You always hear is, well, we have a lot of data that we need to store, and it's not. That's true, but you can't just store it the same way you're storing it today, but faster. It's very, very different on how you have to manage the data. Again, at self-driving cars, all of this information gathering, all of the information processing, and then all of the decision making happens inside the car at the edge. None of the data is going back to data centers stored around the world where a bunch of calculations are done. Our phones today have a lot of AI capabilities built into them as well. So because of that, a lot of this has to change. And technology is also changing a lot of this that people don't realize. So this was work that I did a few years ago. We looked at traditional databases, and we took queries. So a simple request from a database was taking 3 minutes. And we just changed the technology. We changed the underlying technology, and we got it to less than a second. So when you can start seeing that order of magnitude of change, it really changes how we think about a lot of these things. And this is a lot of words, but really what this says is that a lot of people are using their old models to try to design this new world, and that's really not going to work because, again, data are different, data management tools need to be different, data processing tools need to be different as well. So because of all of that, there's this whole need, there's this whole industry almost around a new reference architecture to support AI. And when we started talking about that with some of my clients, what we realized is that there's just new rules that you need to have when you think about how you approach systems around artificial intelligence. And again, when people say artificial intelligence is going to change the world and it's going to be amazing, that's all true, but there's a lot of hard work that has to happen at the ground. And the solutions that you've seen so far, like AlphaGo or the Watson beating the Jeopardy champions, really what that is it's a lot of hard work solving a very narrow problem. And to solve multiple problems, you have to be a lot better about a lot of things. So really quickly, we're going to talk about some big numbers. So I don't know how many people are in this room. There's probably more than 60. But if we wanted to take a combination of everybody in here and we wanted to take their pictures, and we were going to take 1 picture per second, to do every combination, it would take us longer than the universe has been built around. So really what this means is it doesn't take a lot of numbers. It doesn't take a lot of different data points to get really astronomical numbers. That's really simple. And all this information, it creates a lot of complexity in AI too. So when you look at teaching and learning complexity is very, very challenging. There's a lot of different paradigms around instructional design that really affect how quickly and how much data processing you can do. And again, when you look at these numbers, they're orders of magnitude higher than anything that people are really working on now. And the problem is that we don't have a common theory of the mind, and we don't have any means for simulating this. We can't go into a computer and say, show us what learning looks like when you apply adaptive learning to it. We have to actually do this, and there's a lot of work that needs to happen around this. Sorry. So again, when we look at AI, there's these three different levels. So there's narrow intelligence. So what you've heard a lot about so far around artificial intelligence is they apply to one very specific area. This AI program can solve this specific problem. So for those of you who are worried about this, when somebody says AI is going to take your job, they're not going to take your job. They're going to take away one very small part of your job, which gives you more time to do more things, which is actually great. So for AI to be at a point where it can replace you, we're a long way away from that. So in the middle, you see general intelligence, and some of this has been applied, but really this isn't even broadly adopted yet. And then the side closest to me to the far right is the super intelligence. When that comes around, that's when we all have to worry about us losing our jobs, because then computers are smarter than us. They're spawning their own AI. That's a whole it's a whole sci-fi world that's going to happen that hopefully I won't be around for. So one of the other challenges is really around cultural and organizational concerns around AI. So again, you have some people who are saying AI is going to change the world. You have some people saying that AI is evil and we can't let it anywhere near us. So when you talk to leaders about what are some of the challenges, what they talk about is there's a lack of strategy for AI, and they don't have the people with the right skills. So those are these top two right here, is the lack of strategy and the lack of skills. And then there's really a lot of other organizational issues that come up with that as well. So it's very, very challenging for organizations to move to this, but it's also very, very important. And I'm going to talk about some of the steps that we've taken at other places to do that. So institutions really need to start challenging and changing themselves. There's a lot around this that needs to happen. So one is, again, the top one, highlighted one is what I was just talking about, is this something that people are reacting against the technology, or is it something else? In the middle, what you see a lot is that information is siloed in organizations. Information is kept from one place, separate from another place. And in order for AI to really be effective, information has to be freely shared across the organization. And I'll talk about some of the ways in which we're doing that. And then the bottom highlighted one, I think, is also very important, is this whole idea of building your own skills internally, which is very hard, but it's also very persistent, versus going out and finding a vendor who is going to do this for you. There's a lot of fine vendor solutions out there that are using AI, but they are going to be very expensive, or they're not going to be very good, or both. And I've had experience with that as well. So internally, when people are thinking about this, that's really important. So I'm going to talk about some current approaches that we've seen. So and these are places that I've seen this work firsthand. So Arizona State University, which is in Southwest U.S., they're a very large public university. So large in the U.S. is around 60,000 students. It's fairly open. Their president gets a lot of press for doing innovative things like partnering with Starbucks. But one of the things that they also do well is they have this learner analytics hub that they've been building. So right now they've identified 3 different areas where this is going to be useful. One is success coaching. So how do professors and faculty, how do they help students identify ways in which they can improve? The second one is instructional design, is how do they make courses better? And the final one is evidence of learning, and I talked a little bit about that previously, is how do you demonstrate the impact of some of these learning technologies? So, So at Arizona State University, they use a very Amazon-centric architecture. It's, for those of you who are technologists, all of these solutions are very straightforward and simple. It's S3 and Redshift, basically. They bring the data in. And then they use Tableau and R and SQL to do a lot of the reporting out. So one of the other things I want to be very clear about is that this doesn't take a lot of people. At Arizona State University, they've built this entire platform with 4 people. So they have 4 very talented people, but it doesn't take millions and millions of dollars to do this well if you have a good strategy and you have good leadership and you have the right people. So just as an example, there's a solution called Alex, which is an adaptive platform from a company called McGraw-Hill. So this is just a simple architecture showing how the data comes in. You can't really see it, but so it comes into R2, it goes into Redshift, and then the data goes out. And again, what they use this for is they use this for coaching. So this lets advisors see how students are doing relative to their peers. So the orange line is the course average, and then, the blue bars are the range, and then the orange bar is where that student is. So it's easy for advisors to see, are students doing better than their classmates, or are they doing worse than their classmates? The other thing that Arizona State is using this for is really looking at the time that students spend using their tools. So how much they use their learning management system versus their grade. So the grade is on the x-axis, and the time that they spend in the learning management system is on the y-axis. So what this shows is that students who spend more time in their in the systems don't necessarily get better grades, but students who spend less time tend to have worse grades than others. So these are just examples of the types of data that they can get out of that. So the other, another example is University of Michigan, which is a smaller public university in north central United States. It has about 30,000 students. So they're part of the consortium called Unizin. So I mentioned previously that I was the founding CEO for Unizin, and University of Michigan was one of our first customers. So what they're using is they're largely using the Unizin platform, but Unizin again is just this little piece right here, the common data model. A lot of this other stuff they've had to build themselves because that's how they were able to get what they needed. And so they have learning management systems that come in from a batch perspective. This all comes into a data lake. They have various events that come in as well into a data model engine, and then it goes to these event stores that are then sent out. So this is, that's how they're doing those. Sorry, did I mess somebody up? So that's how they're doing the batch system. So the batch data that comes in from various systems. And then, that was the real time. And then for batch systems, they're doing something similar where the data comes in into an ingestion database, and they're just storing it that way. So there's multiple ways in which that they can get this. And again, University of Michigan is using that to ingest their data, and then they've had to build a lot of tools around that. So at University of Michigan, they built a tool called My Learning Analytics that students can use, and they can see where they are relative to their peers and where they are over time. So this is, again, it's the power of having these different architectures in order to do this. One of the things I want to talk about is really this whole consortium model, and what University of Michigan is as part of Unizin is they have the ability to ingest data the same way as everybody else in the consortium. But as you can see, sorry, I'm going to go back a second. As you can see from this, that's actually a very small part of what they need this for. So even though the consortium model helps them get off the ground, it's not necessarily the best way for them to go about this. So I'm going to talk about some of the work I've done at UC San Diego now, and I'm going to go back to these new rules that we had. So University of California, San Diego is also a kind of large public university in California, in Southern California. It has about 35,000 students. The students are very highly educated when they come to UC San Diego. So for them, for UC San Diego, the problems they were trying to solve were very different. But one of the ways in which they wanted to solve it was they wanted to be able to use multiple machine learning models for their next generation learning analytics. So you can't read a lot of that stuff, and it's not really important. But really what this is this right here is the data warehouse. So that's a very small piece of what they want to build. And what they have is they have this very robust and somewhat complicated architecture around how data comes into their systems, how data comes out of their systems, both for upstream and downstream applications. So if there's an application that needs to use the data, they use APIs to send or push that data. But also, we want to be able to take that data from the warehouse and push it to multiple machine learning platforms. We don't want to just be held to whatever system we're on. So we had to, this was our conceptual diagram for how we wanted to solve this problem. The other thing we wanted to do was we wanted to make sure that the student analytics portion of this was really met. So here what you see is you have a student, the student does something, we take that data, we process it, we make some predictions about it, and then we feed it back to the student. And then we have this life cycle around how close are we to predicting what students are going to be doing. And again, this is iterative. We don't expose any of this to the students yet. This is all very, very conceptual, I would say, but it's also allows us to do a lot of experimenting around how data is used. So as we were looking at this, there was a product from SAP called the Student Activity Hub. And I'm going to talk a little bit more about the Activity Hub in a second. But what the Student Activity Hub is, it's a solution that's delivered by SAP that takes in data from multiple teaching and learning tools, and it has pre-built reports out of these. So what you see here is the data comes in, it's processed through these various different standards, and then there's different types of reports that are built. So there's demographic data. So if you want to know how many of your students have come from one city versus another city, you could do that in here. If you want to see how many males versus females you have, you can do that in here. There's things like enrollment that are tracked in here, retention. So all of this is built out of the box, and University of Kentucky and UC San Diego worked together with SAP to develop this product. So this is largely of our design. The way that this data is consumed right now is only through Tableau and Cognos. So all of this data, for end users anyway, comes out in the form of reports. So we want to make it really easy for these end users to have access to this data. Obviously, there's APIs that if other applications need it, but our goal here was really about how we get this. So again, this is done in real time to existing SIS, LMS, and other campus sources. It brings all of the student data together into one place. So the way this architecture works, and I'm going to walk through this because it gets a little, it's a little confusing on this slide. But the data comes in from the system, and then we have this mechanism that basically routes data. So if it's real-time data or batch data, it gets routed to different places. Some of the data goes to this machine learning platform that I talked about earlier. Some of the data goes to an activity table where it's ingested into SAP HANA. And then what we have is we have a bunch of people who create reports. So these people are creating reports that then go out to the end. These happy people here are the end users, but they go out to the end user. So this architecture is very different from what they're doing at Arizona State, and is very different from what they're doing at University of Michigan, because we wanted to make sure that we had this machine learning platform built from the ground up. So the way the data comes in is there's different ways for conforming software, so things that are caliper compliant, for example, data can just come in. For everything else, we had to build various types of integration architecture. So what we looked at was, we looked at this data and we said, down here we have the Student Activity Hub. We have all of these different systems that are coming in. And we realized that this architecture is very powerful. So I was talking to someone earlier today and I was saying, well, now I'm helping them with HR analytics as well. So here we have the Employee Activity Hub. So basically everything, all the data about any employee at UC San Diego is going to be stored there. We have research data as well that we're storing. So we have a Research Activity Hub. All of our finance data will be coming into a single place. We have a Financial Activity Hub. So when we're done with this, we'll have about 9 or 10 different activity hubs. And again, the idea is that all of this data comes in, using those new rules that I discussed before. We don't spend a lot of time organizing the data. The data is simply stored in one big activity table, and then we use that data to do a lot of reports. The cost of querying, like I showed before, goes from 183 seconds for a traditional query to half a second for these. So we can do a lot of queries on a lot of data really, really quickly. I think our biggest table has about 80 million rows, and we can query that in less than a second every time. So it makes it really easy for us to be sloppy on the data ingestion, but we want to be really neat on the data delivery side. So again, this machine learning platform is really about how do we apply our practices to this? How do we take things from Google, and how do we do those as well? So we have a lot of different, sorry. We have a lot of different tools and applications that we want to build on top of these for our predictive capabilities. We don't just want it to be one thing. So when we look at our technology ingredients, we have a data warehouse, which many of you have. We have data management, which we think is a little bit different. And then really where we're trying to differentiate, where I'm trying to help UC San Diego differentiate themselves, is things like machine learning, how do we do data analysis, and then how do the applications use the data themselves. So now let's get back to how universities are using this data. When we looked at this, what we did is, and this is going to be different for every person in every college and university, is we looked at how it might apply across different functions. So we looked at where is AI and machine learning really going to be able to have an impact. So we looked across all of these different areas, and again, this isn't very scientific. It was us looking at the situation, looking at the leadership, looking at what resources they had, looking at the strategy, and just kind of assuming where different things would fall. The other thing that was really important, even though we can be sloppy with data, having a data definition, so the ontology, the structure of the data ended up being very, very important as well. So in some areas, the ontology is very strong, and it makes it much easier to work with the data. So finance data, everyone understands what a general ledger is. Everyone understands accounting principles. It's really easy to work with that data. When you look at something like hospitality, which is around student housing or student meals, that data is a little less structured. The other thing, obviously, was how accessible is the data. So in some areas, the data is not even collected, and in those cases, we didn't want to try to work with them. In other areas, the data was very well organized. Again, finance is a great example, because everyone cares about money. So that ended up being really important as well. And then finally, even if the data is collected, how is the data something that is it objective or is it subjective? Which means, is there variation from year to year over what that data means? We wanted to make sure that the data was consistent over time, because that really impacted how we were able to think about the data. So what we did then is we looked at all of these different areas, and we said, well, these are the functions that we want to be able to look at first. So we came up with an overall score, and we looked at these are areas that are going to have the most impact, that have the most data, and where we can make the biggest difference the earliest. So when we looked at how we wanted to start applying machine learning and artificial intelligence, this becomes really important. So again, when people say the university is going to go away because teaching and learning is going to go away, applying machine learning and AI to teaching and learning, that's this third row right here, is actually very, very difficult. And there's a lot of things where smart people are going to invest their money in places where it's going to have a bigger impact before they start looking at that. And I know people are going to do it because it's a very large opportunity. I understand that. But I also think that that's a much longer horizon than people talk about currently. So again, I talked about this earlier, that there's a lot of different areas that people can apply this to. But really, it ends up being about process improvement and identity and security. That's the biggest low-hanging fruit for AI. For finance and HR, we sat down and we said, where can we start applying some of this AI language? And there's a lot of different opportunities to do this. Sorry, it's a little small. But this is something that is happening throughout industry. So one of the areas that we were able to find a solution was with call centers. So when, as you know, when many of you call somebody, it's usually not a human who you talk to, it's some computer system that routes you from one place to another. So what we did, San Jacinto College is a small community college, so it's a very small public college near Houston, Texas. And what we did is we took all of their FAQs. So on their website, they had frequently asked questions about how do I get financing, where do I park when I come to campus, when do I register, all of those kinds of things. We fed all of those into IBM Watson. So now what they have is they have a series of bots. And what happens is when somebody calls in and they say, I have a question, basically Watson starts looking through all of these FAQ documents to try to route the student to the right answer. And what they've been able to do is they take 1 million calls a year with only 10 employees, which is really remarkable because the majority of those calls are solved through this AI. And obviously the AI gets smarter and smarter over time. So this was a fun project to work on, and it's something that was really, really simple and straightforward once we understood how we needed to architect it and what we were trying to do. Another example is, and I talked about this in the previous section, is Greenlight Credentials, is we helped them use artificial intelligence to start matching job openings to student credentials, basically. So what degrees do a student have? So make that searchable by the employers, but rather than just doing a simple keyword match, we're building a lot of AI tools around that. So just because somebody has a degree in physics doesn't mean they should go work for CERN. There's other things that need to come into that as well. So it ends up being a very complicated model, but it effectively makes the job search capabilities much, much better. So again, I talked about this before. Lack of strategy and then lack of talent are the two biggest things that are hindering people. So how do we get to there? One of the problems that we have right now in the AI world is this rush to individualization. So you hear a lot about this, about individualized learning and individualized tutoring, and everything is going to be custom built for you. So there's three different areas that need to be addressed before you can get this. Is one, do you have the right data? Two, are you able to be responsive enough where you can provide these types of custom solutions? And then finally, it's trust. You have to be trusted by the customers. So there's older companies that everyone knows, companies like GE or I don't know, other companies that have very intimate relationships with their customers, but they don't have a lot of this data. So they're really struggling with how do they start moving to this new world. And then you have newer companies like Facebook and Google that already have this. They have relationships at scale, but really they are losing a lot of our trust because of the way they behave. So there's this middle ground that needs to be found. And the other problem right now is that there's a lot of movement towards a consortium model. So the problem is that the consortium model is broken because there's things that you can collaborate around, but those things are all commodities. But really where you're going to differentiate yourself and where your individualization is going to happen is around some of these experiences that are unique to you. So when we talk to people, we try to help them understand how they're going to move through this. So there's 6 key capabilities that organizations need to have in order to start thinking about how they're going to be machine learning organizations. And this is really the roadmap that we give people. It's really simple. So you want to make sure that you align the leadership. So how do you make sure that you're working on the right projects? You want to plan the journey. You have to know where you're going. If you just say, we're going to build a machine learning practice and you don't have any business objectives or personal objectives around that, it becomes very, very difficult to achieve success. The data collection, I talked a lot about that, but the data collection ends up being important. There's the design experience. So it's how our end user is going to be touched by this. That really makes a difference. If this is something that's that's going to touch end users is either inside your own companies or outside to your customers. It's really important to focus on that. And then you need to empower the community. I talked about trust earlier, and it's really important to think about some of those issues around ethics and make sure that you're being transparent about what you're doing with the data. And then down at the bottom in this gray, it happens alongside everything else, but really it's not the important part. It's the technology and the architecture that's built around it. It's important to have the right architecture, but once that gets going, the other things are much more likely to make it difficult. So again, it's not about being rich, it's about being light. We want to make sure that users are able to decide how they want to use the data, so we don't want to push anything on the users. The technology should be easy to replace. So the work that we're doing at UC San Diego is built on very specific architectures, but it's also built on containers, so we can pick this up and we can move from one place to another really easily. Right now we have SAP on Amazon Web Services. We know that we can easily pick it up and move it to Google Cloud. We can move it internally to our own servers, so we're not tied to any cloud provider. And I think the last thing that's really important, and I talked about this earlier, is that your solution needs to be custom for you. It can't be something that you buy off the shelf and try to fit in, because again, when you start thinking about some of the strategic issues that you're gonna need to solve, and some of your employees and your customers are gonna be very different, so it's important to have your own solution. So again, AI is important, it's challenging, it's changing everything. Leading organizations have taken an aggressive approach to this. So people who are doing this have a very clear project. They know what they want to do. They know how they want to, they know what it wants to look like at the end, and they move down that path. And again, finally, it's possible to do this, but you have to move soon, and you have to go through this. So that is my time. I have 1 minute left, but I think we have time for questions as well. So if there, yeah, so I think that's it.
네, 발표 감사합니다. 네, 강연을 들으면서 궁금한 점들이 굉장히 많으셨을 것 같은데, 지금 이 질문을 올려주신 부분도 굉장히 많은 질문이 올라왔습니다. 사실 아까 들으면서도 굉장히 쉽다, 뭐 편리하다 이렇게 말씀만 하셨는데, 굉장히 어려운 부분을 쉽다고 말씀해 주셔서 저도 굉장히 놀라운 부분이 많았고요. 먼저 간단한 질문부터 좀 말씀을 드릴게요. 유니진에 대한 질문이 있는데, 유니진이 제공하는 머신러닝 모델에 대한 수정이나 재훈련은 어느 정도 가능합니까? 이런 질문이 있는데요.
So the question was, how can Unizin's model be modified to be better? So again, I think what Unizin is, I started Unizin, so I'm a little biased about how good it is. But I think really, again, the challenge is that what Unizin was founded on was this idea around having 25 different universities all have the same strategy, that they would all have the same leadership, that they would all have the same leadership support, and they would all have the same resources. And I think obviously that's never going to happen. So I think the way to modify Unizin is to really start a consortium that focuses on the areas that are interchangeable between different organizations. So I think strategy is something that if people are in agreement on, I think that's really useful. And then I think the technology side, I think technology can be very similar across multiple universities. I think there are ways to do it more cheaply across multiple universities. So I think in those two ways, I think refocusing something like Unizin on those specific areas is the way to make it more successful.
네, 유니진에 대한 질문 한 가지만 더 볼게요. 그 유니진의 경우 사용하고 있는 알고리즘을 대학에 공개를 하나요?라는 질문이 있는데요. 대학에서 유니진에 대한 알고리즘을 어떻게 검증할 수 있냐? 뭐 D2L 같은 경우에 알고리즘을 공개하지 않아서 불만이 있었다라고 하는데요. 그런 부분에 혹시 답변해 주실 수 있을까요?
So I think the question was around Unizin's algorithms that they use. So Unizin doesn't actually build any algorithms themselves. That was, again, that was part of the original mission around Unizin, was to have this shared AI world, but it ended up not happening. So each Unizin institution, I believe, is doing their own algorithms, their own research, their own applications. So what Unizin is doing right now is it's helping all of the universities use Google Cloud Services to move data from the learning management systems into Google, and then from there each university does their own thing. So again, this is an area where I think there's opportunities to improve on the consortium model. I think having universities collaborate on some of the research without actually sharing data is probably going to be much more successful, much more quickly.
네, 그다음에 다음 질문 그 국제 표준에 대한 질문인데요. 현재 어느 정도의 규모와 학교와 기업에서 사용하고 있는지, 향후 얼마나 표준으로 활용될 것이라고 전망하는지 궁금합니다라고 되어 있는데요. 어떤 표준을 활용하는지는 정확하게 말씀 안 해주셨는데 아마 말씀하신 그 교육 IMS 표준을 말씀하신 거겠죠? 그 부분에 네, 말씀을 부탁드립니다.
Yeah, so IMS Global has, and I have the slide, and I already forgot the numbers, but I think it has about 200 different universities and EdTech providers that are part of it. 1 second, I'm gonna verify my numbers. Sorry, 1 second, I'm bringing it up. So IMS Global has 149 educational institutions, 16 government and state education agencies, and 277 education technology suppliers. So IMS Global has been around for a while, and again, even though I have my complaints about them, I think they do a lot of good work. I think one of the areas that in my role as the Caliper Product Steering Committee lead is helping Caliper be more easily adopted, and I think that's going to make a big difference. So I think the work that IMS Global is doing is really good. I think in some ways it's slowed down again by this whole consortium idea that they have to have hundreds of people agree on every solution. But I do think that when they come up with a solution, it's very robust and it sticks around. LTI has been around for probably a decade now, and it's only getting better. So I think IMS Global is a great organization that, again, the other thing I'll say is that IMS Global also needs more voices in it, so more diverse voices to hear about how other people are solving their challenges. So I think engagement with IMS Global would only make it better.
네. 다음 질문 아마 일반적인 질문인 것 같은데, 민간 기업에서 캘리퍼를 사용하려면 IMS 글로벌 회원사의 자격이 필요한가요?라는 질문인데요. 이것도 참고적으로 한번 답변을 들어보는 게 좋을 것 같아서요. 저기 가운데에 있는 질문 한번 보여주시겠어요? 크게.
Sorry, the end of that question was cut off.
네, 민간 기업에서
okay.
캘리퍼를 사용하려면 IMS 글로벌 회원사의 자격이 필요한가요?
No, you don't have to be a member of IMS Global to use any of their standards. What membership gets you is it gets you support from the IMS group themselves. You can also engage outside contractors like myself to help you with that. And the other thing that it gets you is when you go to the meetings and they're making decisions about Caliper 2.0, you get to have a say in what that looks like. So in order to use any of the IMS standards, you don't need to be a member, but being a member obviously lets you have a voice and gets you more support.
네, 감사합니다. 전문가 분이 한 분 계신가 보죠. 계속 질문을 굉장히 많이 올려주셨는데, 네, 캘리퍼 애널리틱스 스페시피케이션의 내용을 어느 정도 준수해야 표준을 적용한 것으로 볼 수 있나요?라고 되어 있는데요. 그 기준 같은 부분이 페이지에 나와 있는 걸 알고 있지만 한번 말씀을 좀 들어보겠습니다. 캘리퍼, 네, 요 질문입니다.
In order for Caliper to be standard compliant, I think there are only 6 fields that you need to have. So when I showed you the very basic view where it was an actor, an action, an object, and a date and time, that's roughly the minimum that you need to be Caliper compliant. Anything more than that you do is obviously up to yourself, but as long as those fields are compliant with the standard, you will be Caliper compliant.
네, 다음 질문은 저도 개발 전문자는 아니지만 한번 요거는 물어보고 싶은데요. 캘리퍼 서비스를 구현하는 방법 중 자바스크립트 기반 백엔드에서 구현하는 방법은 없나요? 정확하게 무슨 질문인지 잘 모르겠습니다. Node.js에서 구현할 수 있는지 물어보셨거든요.
Yes. So there are so the question was so there are endpoints for Caliper in many different languages. So there is an endpoint for Caliper in Java, so it can be used with that. There's endpoints in Ruby, there's endpoints in iOS, so Caliper can be used with multiple languages fairly easily. And if you send me an email afterwards, I can give you more information.
아, 네, 알겠습니다. 지금 처음에 올라왔던 질문인데요. 블록체인 관련해서 아까 내용이 있었습니다. 그래서 블록체인이 보안 문제에서 완전히 자유롭지 못한데 이에 대한 어떤 보완책이 있는지요. 그리고 그 근간이 되는 플랫폼에 대해서 안전성을 어떻게 보장할 수 있습니까? 라는 질문이 있습니다.
So the underlying architecture so Greenlight Credentials is the company that I've been working with, and underlying that we are using IBM Hyperledger is the blockchain fabric that we use underneath that. So blockchain itself is not 100% secure, so we have some additional security measures that we put around that. So one is that obviously all of the data is secured when it's stored. It's secured and encrypted when it's stored on the blockchain and also when it's in transit. So we're able to remedy that. And then we also have some other verification techniques below that. So it's basically a blockchain on top of a blockchain, I guess, is one way to think about it. So we verify the data. It's encrypted, but we verify the encryption a second time. So yeah, blockchain is not 100% secure, but for our needs, we have been able to secure it to our needs anyway.
지금 방금 막 올라온 질문이 하나 있는데요. 캘리퍼가 현재 단넷 4.5 버전을 지원하고 있는데 그 하위 버전을 사용할 수 있는 방법이 있나요? 라는 질문을 해주셨습니다.
So Caliper right now is relatively new. So they have just announced that they are going to stop supporting Caliper 1.0. They announced 2.0, I think, this last summer. So there's not a way to use older versions of Caliper. One of the things that IMS Global and me in my role are trying to do is make sure that when the new standards come out, we don't break any of the old stuff. So all the forward Caliper versions will be backwards compliant, but you can't go back and you can't be certified on Caliper 1.0 any longer. I hope that answers the question. Sorry.
질문 답변이 더 많겠지만 일단 질의응답은 여기까지 끝내고요. 쉬는 시간을 30분 동안 갖고 저희는 트랙 D의 두 번째 시간은 3시 반부터 시작을 하도록 하겠습니다. 다시 한번 좋은 강연과 말씀 주신 아민 카지님께 큰 박수 부탁드립니다.